one of the nice things about classes is that we can also set up a class so that we can inherit from them. So let's do this. Let's make a class called animal. And so we'll make this animal class. And then we're going to make an init method. Well, actually, first let's just define some methods. And let's diagram this out. We'll make a new blank document. And let's see, we're not doing flowcharting, we're not doing shapes. We want UML. And so we'll make this animal class. And let's see, well, what we're going to have some attributes. I think probably, let's start with just describing what animal does. We'll probably have make noise. Of course, always have self. And so that means we need some attribute here that is the noise. And let's see, what else do we want it to do? Oops. We want to get description, maybe. And then, of course, that means that we need a set. And we're going to do this a little differently. We're just going to do it like this with some attributes, I think. And so we'll just play with that. Let's try this out. So let's make this class. We'll define our double underscore init method. And we will, in this, say self dot description equals I am a generic animal. And we'll say self dot noise equals I am making animal sounds. And then what we'll do is we will write our get description method that just takes self. And in this case, we're not providing the person using this class the ability to change things. We're just going to initialize them, and we'll just be able to get things back. Basically, these are all read-only. So we'll just return self.description. And then here we'll define our make noise of self. And we're just going to print self.noise. And so we'll make an animal. We'll call it generic animal is equal to animal, and then we will print generic animal dot get description, and then maybe we will do generic animal dot make noise. So both of these will be printed out. This one because it's going to get the description from animal, and here because we're going to actually just call the make noise method, and we see I'm a generic animal. I am making animal sounds. Now let's say that we want to make another class called lion. And lion's going to inherit from animal. So now, for the first time, we have a class which we put parentheses. And what these parentheses say is lion will have everything that animal has. And in fact, what we're going to do is we're just going to say pass. And then we're going to say lion1 is equal to we're going to instantiate a lion, and then what we're going to do is print lion1 dot get description, and we're going to say lion1 dot make noise. Now hold on a second. Now pass, what that means is it just tells Python, hey, I don't want to do anything. So when you put a colon, Python's expecting a statement to come after it. If you don't really want a statement after this, like we want to temporarily with this one, we're just going to put pass, meaning this class essentially has nothing in it, or at least appears to have nothing in it. But down here, notice that I am calling the get description method. And down here I'm calling the make noise method. Well, lion doesn't have a get description or make noise method, but it's inheriting. So let's see if it got the get description and make noise method from the animal class. So let's run that. And it does. You can see here it is actually working. Of course, we don't really, we can't really tell the difference between this. So maybe what we'll do is we're going to expand our animal class, and we're going to, we need our animals to have a name. So we're going to make get and set methods for names. So get name of self is a method we need, and we're going to also add in a set name self comma name. And then what we're going to do is put in here a name attribute. Let's put it up here because so it stays all in the same order. Makes it a little bit easier to see what's going on. So in here we will say self.name equals no name yet. Just to have something to say. And then we're going to make our set and get method. So def set name of self comma name, and we're going to say self.name is equal to name. So now we have a name, and then we're going to define get name of self, and we're going to say return self.name. So just our generic way of making a set and a get method, so we can set a name, we can initialize it, and now let's see what happens here. So once we have that set and get names, what we can do now is we've created our lion. Let's say lion1 dot set name, and we'll set the name to Leo or something like that. And then what we do is we have make noise, and then let's see, we can say print. We'll do a format string here. My name is lion1 dot get name. And so now we are getting a name, and then here we'll do the same thing for our animal. So we have our generic animal. Oops. So here we're going to create a generic animal, get name, just to see what, what gets initialized. So we'll probably say no name yet. Then we'll get the description. Then we'll make the noise, and then we'll create line 1. We're going to set line 1's name. And again, notice line doesn't have a set name, doesn't have a get name. It's getting all of this by virtue of the fact that it's inheriting from animal. So this code right here says inherit from animal, and that means all these methods and all these attributes are inherited. So let's run that and see what happens. And we can see my name is no name yet. I'm a generic animal, making animal sounds. My name is Leo. I'm a generic animal. I'm making animal sounds. Now, so this is basically inheritance at this point. By putting this parentheses in, we inherit all of this. Watch what happens if I get rid of that. If I just make line an empty class and run this, I get an error. Lion object has no attribute set name. Because I got rid of the inheritance, it doesn't get set name back from animal. Inheritance basically means take everything from this class and give it to this class. And so what it allows us to do is not repeat ourselves. This is called the dry principle. This is inheritance. Or actually, don't repeat yourself. That's why it's called dry. So DRY, don't repeat yourself. And by doing this, if we need this class to have everything that this class has, we can do that. Now, this wouldn't be very useful. I mean, why would we need a class that's empty if we already have one that does it? We could just make everything be an animal. Well, let's say we want to make some things unique. Well, one thing we can do is we could define a function that is unique to this animal. So we could lions like to sleep, so we're going to say that it has a sleep function, and it's just going to say print this lion is tired. So now we have lion is going to inherit everything from animal, but it's also going to have its own additional method called sleep. And so lion1 can sleep now. Generic animal, on the other hand, can't sleep. Watch what happens if I try to make generic animal sleep. Animal has no object sleep, so this can't be done. Because sleep is a function that lion can do, but animal doesn't have a sleep function. Now, perhaps not all animals sleep, so we are only going to provide that to lion. Now if I run this and I take the sleep method out from generic animal, we can see lion is tired, sleeping. And so why is this? So let's diagram this out and show a little bit what's happening in more detail here. So we have animal, and then what we do is we have this other class called lion, and it's inheriting everything. So we could write everything all over again. What's going on with this thing? But with UML, we actually have a shortcut to do that. We can just do this. We put an arrow, and what an arrow from one class to another implies is that this class inherits from that class. And the only thing that we've added is a sleep method. So lion has everything an animal has. It's almost as if all this was in here too, but we're making lion inherit from that and just having it get sleep. So let's look at what that, go back to the code and look at what that that looks like. It's getting a little messy. See if I can move this a little bit closer. There we go. And so we have this animal class, and then we have this lion class. And this lion class, notice that the only thing defined as lion class is this sleep method. But by virtue of the fact that we have inheritance, i.e. this arrow here, lion also has all of these methods as well. So it saves us some time and repetition. It also makes it much easier to maintain, because if you make your classes this way, then you don't have to repeat the same code multiple places. And let's make a class called bird. Bird is also an animal, but it's going to have the ability to fly. And so we're going to have it, so we made this class now called bird, and it's also inheriting from lion. And so now we could make a bird1 is equal to a bird, and it can do all the same things. You know, we can set name by virtue of inheriting from lion. And then we'll print out its, we'll get its name, just like we did with the lion. And we'll print out description, and it's inheriting that from animal. And then we'll say bird1 dot make noise, and bird1 dot sleep. Now, for example, if we tried to, let's see if we can sleep. And then bird1 dot fly. So if we run this, we're going to get an error, of course. And it says, bird object has no attribute sleep. So here when we tried to sleep, it said it couldn't find it. Well, that's because lion has the ability to sleep because we gave it a sleep method, but bird doesn't. On the other hand, bird has a method, has the ability to fly. So we can't do this. But it can fly. So if we do that, it's getting messy. Let's try again. We can see that our bird is flying. Now, so that's pretty good. Let's diagram that up. We can just copy this, and we'll say this is actually bird. And we have the fly method. And this is also inheriting from, let's put it over here just so that it's a little bit. So, bird also inherits from animal, lion inherits from animal, and these are both animals, but they have unique characteristics. Now, one thing that's not really great about this is they're both generic animals. Well, they're not really generic animals, they're pretty specific. So what we can do is we can override the method in animal. So lion, we can say, you know what, I don't like what get description is doing in the generic one. So what we could do is we could make its own generic method. And we could say get description of self. And if you do this in Visual Studio, it's going to automatically type in return super.getDescription. And what this does is this would actually call, like right now, this actually doesn't change anything. Notice that, let me try running it again. Notice that Leo is still a generic animal, because what ends up happening, let's put a stop point here. And run in debug mode. When we get to this stop point, I'm going to step into this function, which will step into get description. It goes to lion, goes to the, notice that it's going to lion's get description, not animals. Because lion has a get description, it won't go to animals get description right away. But in this case, because we have return super get description, if I step into that one, now it goes to animals get description. I will then, and then it comes back and we get I'm a generic animal. Now, probably we don't want that. Instead, we don't want to use, we're not going to leave lion's description here, we're going to put in our own description. It says, I am a lion. So now when we run this, see that the description now, rather than generic animal, is using our very specific one. So lion has its own get description. We've overridden animals get description. So from a lion, when you call get description, it is no longer using animals get description. It's using lions get description. Bird, of course, is using birds get description. So actually, this should be bird1.get description. Let's try it again, make sure that didn't really change anything. Yeah, I'm a generic animal. So we could do the same thing with bird as well. We could say, you know what, we need to have its own description. So we're going to override get description. And we're going to return I am a bird. So again, because bird has its own get description method, we can see now it is using that description that we have here. Now another way we can do this is actually going into the bird class and just changing, saying description is equal to I am a bird, in which case we don't need to override actually, no, we do need to do it that way, because notice that this does not override animals to get description method. The get description method is using self-description. So what we could do is override the init method. And instead bird's init method will say I am a bird. I'm making bird sounds. And let's see what that does. So now, rather than overriding the get description, bird is still using the basic get description method. But because we overrode the init method, it has different values here. So there's a lot you can do with inheritance. You know, we can inherit from another class, get all of the methods that were defined and attributes that were defined in that other class, and just use them as is. We can add new methods. Or we can override base class methods. We can even override base class constructor so that our derived class, our child class, is constructed a little differently. And this is just another new method. So this can allow you to organize your code in a very efficient way. Done properly, you don't have any repetition in your code. You reuse the pieces you need, and you have the ability to create different objects that have a lot of the same features, but sometimes have things that are unique to those particular classes. So that is basic inheritance. Thank you very much.